Good afternoon, everybody, and welcome to the PackHub's latest webinar. My name is Paul Jenkins, Managing Director of UK Packaging Innovation Consultancy, the PackHub. Many of you will know me and the business. So welcome again to this webinar. We're doing something a bit different today. You'll see I'm wearing a lab coat and some glasses. So very excited to be in Xampla's facilities. They're a material innovation company based in Cambridge. And today, Xampla and NPL, which is the National Physical Laboratory, will discuss how plastic-free can be validated. So no lab visit is complete without doing a live demo. So Blue Peter once said about working with children and animals, but doing live demos for webinars is also sometimes a foolish thing to do. But I'm going to do a demo on Xampla's Morrow brand. And a challenge for a business like Xampla, and we'll hear a lot more about their technology and how it works in a moment. But one of their challenges is to deliver the same performance as for plastic coatings, so in terms of grease and water. So what I've got here is some grease, and I'm going to pour it on this Morrow coated box, and hopefully you can see. Absolutely fantastic barrier, nothing coming through there. In fact, we did a test about an hour ago, and I'll even put that above my head with no risk of getting any content on me. Again, we can do the same with water. Pour it on there. You can see the water sloshing around. Nothing happening. And again, some of the water has evaporated from an hour ago, but I'll do the above head test. And that's all good. So many of your customers care about plastic-free, but does your packaging truly stand up to the claim? So delighted to be joined by Mark, who's founder and CTO at Xampla, and Max, who's a fellow at NPL, which is the National Physical Laboratory. Q&A session. So please make sure I've got a Q&A session at the end, so please make sure you get all your questions in, and we're going to have a nice 20-minute, 25-minute opportunity to ask Mark and Max as many questions as you like. So please get those questions in. I'm sure you have loads. And thank you, and I look forward to the next part. Thank you.
Hi, everyone. Good afternoon, and thank you very much for joining the webinar today. So as Paul shared in the introduction, today we're going to be discussing a little bit about the work we did jointly with NPL about how we can demonstrate that some of the materials we develop can be plastic-free, or we can actually demonstrate that they do not contain plastics and how they actually stand up to the claim. So first of all, I think we'll just start with a couple of introductions. So I'll start. So I'm Mark Rodriguez, and I'm the CTO and co-founder at Xampla. And very brief introduction. So my background is chemistry. I studied chemistry. And for the last probably 15 years, I've been working with natural polymers, proteins specifically. And as part of that sort of initial academic work, we spun out Xampla, which is a materials innovation company. And I'm joined today by Max, who will introduce himself now.
Yeah, hi everyone. It's a pleasure to participate in this webinar. My name is Max. I'm an NPL fellow in biometrology. My background predominantly in biophysical measurements, audition from protein to cell systems biophysics. So more recently, we set up a biofoundry, a UK reference biofoundry, which will be supporting the engineering biology industry. And this is in the spirit of NPL in general, because National Physical Laboratory is National Metrology Institute that is responsible for development reference standards for UK PLC in all its diversity, from quantum technologies all the way to engineering biology. So that's my contribution predominantly here, is just to give you flavor maybe of what NPL does and what in this particular project, how we helped Xampla to validate the material.
And just as a tiny introduction to Xampla, so Xampla is a materials innovation company, unlocking the power of plants to create materials that change the world. And specifically within the context of the discussion today, one of our products are Moro coatings, are coatings which are based on natural plant polymers with no chemical modification, and they are now commercially used in single-use packaging. And we actually will demonstrate today that our materials are plastic-free as part of the work that we did jointly with NPL. So how can we actually identify whether our material is plastic-free or not? So obviously there isn't like an internationally recognized standard that everyone can follow at the minute, and hopefully as part of the work we've done with NPL, these are the first steps in the journey to be able to achieve that. So there's a very sort of established sort of set of tests and standards that everyone can follow. But what we have now is actually related to some definitions that are part of the Single-Use Plastics Directive, but also definitions which are captured in some regulation as part of REACH or also the European Chemicals Agency. So probably a lot of companies in the audience today, they're trying to make assessments on whether some of the materials they're testing and evaluating in their packaging solutions are plastic-free in the context or in relation to these definitions. And just for context, I think the scope of what we will present today, it's not to debate whether we agree or do not disagree with these definitions. So these are definitions that are set by European Commission or the European Chemicals Agency. And what we will try to do today is to actually understand, based on these definitions, whether some of the materials we've developed, and actually also based on the work that NPL have done, they meet the criteria of these definitions, and also to show the work we've done to validate that they fulfill the criteria which is described in these definitions. So just as a general sort of overview of these definitions, what we've done is following some of the text on the Single-Use Plastics Directive, which defines plastic as a material consisting of a polymer. And luckily, we also have definitions of what is a polymer in REACH. And I'm not going to go into the detail, but I think what's interesting about these definition of plastic is that there is an exception. So natural polymers that have not been chemically modified should not be considered plastics. And also, luckily, we have definition of what is actually a natural polymer. So that's also, there's some information in some REACH and European Chemicals Agency guidance on monomers and polymers. And that refers to polymers that essentially where the polymerization has taken place in nature. And we're also aware that some natural polymers could be also produced by fermentation. And actually those actually are excluded by this definition because it is specifically mentioned that the polymerization needs to take place in nature. And also we have some definitions of what is not chemically modified. So based on this, and if we look at the diagram we built together to try to follow the decision tree, it becomes very clear that the types of materials that should not be considered a plastic either are materials which are not polymers, or also the only other option would be materials that are natural polymers and have not been chemically modified. And examples of those types of materials are essentially materials like proteins, which can be animal or plant-based, lipids like vegetable oils or waxes, polysaccharides. We've seen lots of examples. They're already used in the packaging industry, like starches or different types of cellulose-based materials or seaweed-based materials, and also lignin, which is one of the most abundant and natural polymers in the planet. So that gives us an understanding of which type of materials we can already use for lots of different applications in packaging specifically, which should be exempt from the Single-Use Plastics Directive, and they should not be considered a plastic. So yes, just to summarize, I think it is clear from the definition what materials should not be within the scope of the Single-Use Plastic Directive. But the challenge, I guess, is even if we follow these definitions and we're very confident that our materials fulfill all these criteria, how can we validate that? And how can we provide evidence and data to substantiate those claims? And I think that's one of the main challenges that a lot of companies are navigating through at the minute, because first of all, there isn't an internationally recognized standard that everyone can follow. So there's lots of different companies that are trying to make their own assessments. And that's the main reason why we decided to start this project with NPL. And just make it a bit more specific to our materials. Here is just a summary slide that explains a little bit what we do at Xampla. So fundamentally, we use natural polymers that are extracted from nature. So the polymerization process takes place in nature. And then what we do is we take these natural polymers, in this case, specifically plant-based proteins, and we process them to change essentially their molecular structure, but we are not changing their chemical structure. So there is no chemical modification. And that allows us to improve the functionality of our materials. So we can improve the barrier properties, as they were mentioning before, as a grease barrier for paper, or improve the water resistance, but without any chemical modification. So from that point of view, we should be compliant with the Single-Use Plastics Directive. But something that we need to validate is whether during any of these processing steps, not just during the manufacturing of our material, but once our material, for example, is applied onto paper, it will experience some heat, it will experience some drying conditions, and all these different processing conditions potentially might lead to some changes in the chemical structure. And whilst we are very confident as a company, and because we understand our chemistry very well, and we are 100% sure that those chemical reactions do not take place, we still need validation. We need experts to be able to look at these materials in detail, and we need the experts to validate and demonstrate that actually, in fact, no chemical modification is taking place, and therefore we can actually completely validate that our materials should not be considered plastics, and then we can substantiate our claims about our materials being completely plastic free. And that's fundamentally the work we started with NPL, who are essentially the national sort of institute when it comes to measuring in the UK. So we're very glad we were able to do this work with an expert team led by Max, and I'll let Max start explaining the work that we did as part of this project.
Yeah, so the biggest challenge here, as Mark was explaining, actually was not just even to confirm there are no chemical modifications, but to confirm what chemical modifications were meant in those regulations. The regulations are fairly vague on what modification is. So if you introduce a new chemical modification, it's very easy to pick up, and that will be pretty straightforward way of confirming whether it's plastic-free or plastic-dependent material. But very often it's about the modifications of the same chemistry, meaning that more of the same bonds or more of the same chemicals you see in the material after manufacturing process. So and that's the biggest challenge here. And if you demonstrate that, that's pretty much meets the regulations or current directives, or their definitions of what alternative plastic could be, a plastic-free material. So that's what we start doing here, and that's what we've done, for example, so far. And it's important to emphasize that it's not just one method we develop. We have several methods. We perform them in a correlative manner that will be chemical and physical, such that different information from a different method we will compile into one data package that will actually confirm that one claim is true or not. Can we go for next one? Right, this is a good kind of example of what we call fingerprint signature. Any chemical or any molecule have a chemical signature. Very often they are very similar, but some of them can have unique signatures. So in this case, we consider in proteins. And the key point here is the final stage of the manufacturing that Xampla applies. When you have a starting material, you apply it to make finally a coating, how that material changes, or does it change at all? And I write the spectra of these curves. You have two curves. You can see they're nearly identical, one before processing, the other one is after. And it's important even to look at the 1500, 1600 range, which is most important for proteins, because that's where the chemical signature is considered to be informative of a protein rather than any modification. But the other point, very important one, is that very often you can have the same chemical signature, but more of it, or it's a question of quantification. Do you introduce the same chemistry that you already have in protein while you're processing the starting material. And here we show that based on identical signatures, we don't have more of that material. However, I have to say that it does require some work in terms of standards and regulations, because there's no definition of to what extent we can quantify it. We're talking about trace analysis, any traces of particular bonds, or is it just general global effect? So as it stands, we can say that the materials are identical before and after the process. So we have also this extra image. You can see orange one, it's atomic force microscopy. It's not chemical signature, it's a physical, but it's fairly unique because we know Xampla materials for quite a while, but this one was striking because it shows very homogeneous, very thin layer, which is very well organized. It's not just molecular, it's supramolecular interactions, which are pretty much what they do for your plastic-free material for a coating. And that's pretty exciting. So it would be an extra bit of information for us to develop new standards. Next one.
Yes, and I think following on Mac's sort of summary of all the tests that was done, obviously, you know, one of the main sort of conclusions of the work is that, yes, we couldn't really identify any chemical signature differences before and after processing, and therefore we can conclude that our materials have not been chemically modified during the manufacturing process, and therefore they are still natural polymers that have not undergone any chemical modification, and therefore they should be considered plastic-free if we follow the definition of what's a plastic according to the Single-Use Plastics Directive. I think from that point of view, we've completed our work, but I think it doesn't end here. I think there's still a lot of work to be done in this area, because we've just tested, you know, our material with a set of you know, really sort of like deep expertise sort of set of analytical tools. But I guess we want, you know, these sort of framework to be developed and to be available to, you know, everyone in the industry. And I think one of the main you know, sort of learnings of doing this project is that, you know, these lays the foundation for, you know, starting to develop internationally recognized standards so that other companies can follow the same procedures and protocols, and we standardize these tests across, so we don't actually end up having lots of different companies doing their own tests and not being able to peer review, almost like whether we're all following the same standard. So I think one of the most immediate next steps as part of this project would be to continue trying to make sure that other companies try to follow the same approach, and we get like key industry players talking together to see whether we could all sort of agree in starting the journey to developing internationally recognized standards. And I think, you know, as part of this, I think this is all going to help gain credibility, because I think especially there's been recently, I guess, some question marks about some claims about, you know, some materials being plastic free or not. And I guess, you know, sometimes that can be quite damaging in terms of reputation to companies if actually they don't have the right tools to actually have the right analysis and to be able to make the right decisions. So I think once we're able to put together, you know, the right standards, it's going to help, you know, all the packaging industry to accelerate the transition to truly plastic-free and unsustainable options. And I think that's pretty much the end of the presentation. So thank you very much for your attention, and I'm sure hopefully there's going to be a few questions that we'll be really happy to answer. Yeah.
So I'm back, Paul Jenkins, lab coat free. So what are sort of the first sort of questions come through? So what are the next steps for making this a standard?
I'll let Max probably answer.
Yeah, so yeah, before that, first of all, it's very important that the industry inform us about what standards are needed. That's why this project is very important. And I kind of won't praise much Xampla, but I would have to give them some praise. They were first to initiate this kind of discussions because of the lack of regulations. And if you lack regulations, you actually lack the commercialization opportunities for yourself, so that you can't really develop a product and get them into market. So the standards are to inform regulations, on the other hand, and also to support companies to accelerate their development. So now, how far we can go with this? We can go as far as possible, and we don't really depend on regulations, what they say, what plastic-free is. So we can define it by ourselves, and we can talk to them, and they would decide at the end what they really like it to be as a plastic-free definition. To develop a standards, there are two types of standards. The one will be what we call etalons. Those will be reference materials, the physical standards that would be used as a method or material to compare your commercial product against, or your precursor product. That's what we do in NPL. We also co-develop our documentary standards, norms, or ISO standards that will define or give a technical specifications of those etalons or reference materials. And all of it is linked together with regulation in one ecosystem. So I think the start here is already done. Now we need to define what this standard is going to be, what are the metrics, even though we have a particular ones in mind, and to move on with the comparability studies, which are pretty heavy very often. That means that we send a set of materials across the world to different laboratories, such as ourselves and many others, and we come up with a consensus values. That will take from 1 to 2 years, depending on how quickly you want to do it. And then, of course, it will be a defined standard as an etalon, which NPL or any other metrology institute can certify. Once we've done it, then it actually direct help to industry, because then we can issue certificates of analysis or traceability, which is even better, to confirm that your material is actually strong or your claim is validated. And that can go to regulation, even if it doesn't exist yet, but it will inform them. So that's kind of the scenario, most likely.
Excellent. Thank you very much. Make sure people continue to get your questions in. We are very keen to find out more. So another question has come in. So what should brand owners be asking for when they are given plastic-free certification documentation from suppliers? You know, what kind of challenging, what kind of things should they be looking out for and asking in terms of that certification?
I think a very simple one is to be able, that information in terms of the composition of the materials is shared openly. Because if, for example, a natural polymer is used as part of that formulation, then people can follow that decision tree. If there is some information as well that material is chemically modified, like by the presence of other additives, for example, then they could try to essentially identify whether fundamentally that followed certain path in the decision tree, and then that should be not considered plastic-free, or it should. So I think being able to share the composition of the materials is a really good starting point to determine whether those polymers actually fit within the definition of polymers, or actually they are excluded because they might be natural polymers which are not chemically modified.
Okay, brilliant. And is there a drive to develop a global standard? I mean, maybe I missed it, but is there an opportunity to develop something that is used across 220 countries or whatever around the world? I mean, is that an aspiration for us at some point?
Well, it will certainly help, because that will promote international trade, and of course that's what you want in the end. What is going to happen? It's hard to say at the moment. It's early stages, because I think the challenge from our perspective, from Metrology Institute, will be, what are we talking about when we measure the chemical difference? Is it a trace analysis, or is it just, as I mentioned before, or is it specifically quantified value that we need to demonstrate, or you need to demonstrate, that would meet the requirements, non-existing regulations, that your material is plastic-free? So the global, absolutely, it will be fantastic if we have it.
Yeah.
But
okay.
Will take longer.
Okay, how long?
Well, it can take up to 5 years, even more. But remember, everything can be accelerated, and especially when the industry jointly pushes for a standard, it's much quicker, because then it becomes a priority. And of course, it all depends on how it's funded, but yeah, the priority is defined by industry.
Excellent. Okay, we've got some questions about Xampla's Moro coating. So someone asked, a very curious question: can you eat Moro coating?
I mean,
in theory,
in theory,
or, and in practice.
Obviously, our motor coating is designed as all barrier coatings to provide protection to paper against grease, against water,
food contact, yeah.
and to not migrate into foods, because obviously, there's regulation about migration of food contact materials as well. However, I have to say the same technology or similar technology that is used for our motor coatings has also been developed for other applications which are not on packaging. So we're using very similar technology to actually coat active ingredients in food and beverage applications.
Okay.
Almost to micro package things like vitamins and oils.
Yeah.
So that same coating we're applying on paper to provide protection, we can actually provide that same protection to foods. So actually we can extend the shelf life of active ingredients.
Okay.
We can control the release properties of those active ingredients. So our technology expands across lots of different areas. One of our main focus now is barrier coatings. But yes, fundamentally, because the ingredients we're using can be food grade, certainly, I would not recommend anyone eating a takeaway box with our coating. And that would be a bad idea.
Not be tastier than the food.
Probably, but if they did, that wouldn't actually be a problem at all.
Yeah. Okay. Another question about your coatings. Just a curious one around sort of key applications. Where do you see your coatings be best used? Can they be used, for example, in food service cups, hot and cold?
Yes, and I think that's part of our sort of like strategy. So at the minute, our coatings are best suited for food service applications, especially food service applications where you might require grease barrier, some water resistance. Our coatings today are quite good when it comes to water resistance, but I wouldn't be able to say today that they're absolutely ticking all the boxes for hot coffee cups. That's something we're actively sort of developing. So hopefully within the next year, we'll be able to offer a solution targeting those more challenging applications, because that's one of the main benefits of plastic, which is like they come with lots of issues from an environmental point of view, but they're really good from a performance point of view. So our challenge as a materials innovation company is to be able to develop plastic-free solutions that can deliver similar performance to plastic without all the negative side of what plastic contributes in this type of applications.
Okay, brilliant, thank you. Back to sort of plastic-free and the process that you do to get there. Have you discussed your methods findings with the EU and get their approval for your materials to be used as compliant under PPWR? A very topical question.
I guess I'll let Max answer that.
Well, we certainly haven't discussed as probably a company to discuss that, but the question is what to discuss. To present the data and say this is how we see and how we see the material meets the requirements, which are again very vague, or to have a discussion to extend the requirements to make them more clear in quantitative terms. So that's certainly buffer short, and we already said that the entire initiative to develop standards and regulations, this is in tandem, not just one or the other, will have to start with discussions with interested parties.
A question around the sort of the testing process. So what are the conditions of the industrial testing? Were there special conditions for heat, for pH and things like that? Are you able to sort of explore a bit more about the testing process?
I think obviously we tested the raw materials, and then we tested the raw materials after processing. And I think what we were trying to mimic there is the process conditions that you would normally find when our materials are applied onto paper and dried onto paper to create a barrier coating. So typically those conditions include high temperatures and time. So that's fundamentally what we try to mimic. And I have to say, a lot of these tests, we made the samples at lab scale, which, I mean, the conditions when we made the samples at lab scale are much more aggressive to the ones, you normally find when you're applying, this coating at hundreds of meters a minute, where the exposure to high temperature is literally fractions of a second. So, yeah, I mean, certainly high temperature is fundamentally the main sort of condition we tested, because we also know that that's when potentially some chemical reactions could happen. But even in the worst case scenario, we couldn't actually see any chemical changes.
Okay, brilliant. You talked at length about the specifics of the creation of obviously alternatives to plastics. You may not be able to answer this with an extreme amount of knowledge. Is there do you think there's similar work, or do you know if there's similar work on the reclamation, degradation, and the recycling of these alternatives. So you're obviously trying to solve one part of it, but there's the whole sort of end of life things to sort as well.
And in this particular case, obviously, we're applying our barrier coatings onto paper, and obviously, paper it can be widely recycled, and there is a very well-established infrastructure to do that. So part of the work we've done in parallel to the work we've done with NPL is to demonstrate that our materials are fully compatible with the recycling infrastructure. So we've sent coated paper samples, actually different combinations of our coatings, to a test lab that fundamentally is trying to mimic what would happen in a recycling paper mill. And we got the score. So fundamentally, we validated that our coating, because it's applied on a very thin sort of coat weight, it completely is compatible with paper recycling processes. And the material itself is completely biodegradable as well.
I was going to ask about the end of life options or scenarios for a Morrow takeaway box.
So fundamentally, in that case, one of the scenarios would be if that box goes into a recycling paper mill, for example, the coating itself will be easily separated from the fibers. The fibers will be able to be recycled, and we've validated that with these tests. And also in parallel, we know that our material will easily biodegrade. We've done biodegradation tests in fresh water, which will mimic the conditions that you will find in a wastewater treatment plant. So fundamentally, from that point of view, we know that both the paper can be recycled and the coating will be completely biodegradable. So as opposed to traditional synthetic polymers or plastics used in those type of applications, the barrier coating itself will completely biodegrade. It will not contribute to microplastic pollution, or it will not compromise the recyclability of paper in a paper mill.
Okay, brilliant. A couple of questions around moving this forward to a wider audience. So will you be making this publicly available for future use and additional use?
Yes, I think Max.
Is it the question to standards or methods? Publicly available
research. Will you be making sorry, I missed out a very key word there. Will you be making the research publicly available?
Oh yes, absolutely. We are, unless Mark changed his mind, but we think about publishing the data, and the reason for that is exactly to inform the community and get the feedback from them, because we're pretty sure there will be a lot of support, but also a lot of challenges. Xampla is not the only company doing this, and also there are companies who are using still plastic-based materials for similar stuff. And then it will be interesting to see how it all develops, but we definitely publish the data shortly, maybe within 6 months.
Okay, Max, are you seeing different use of language now because some companies realize that they can't say plastic free? I mean, 3 or 4 years ago, there was a gold rush to sort of make these sort of environmental claims, and obviously laws have come in to put that, just to really stop that. But are businesses sort of reducing those claims because they can't say them, or
no, they can. It's just, I think the general problem is that there is a strict kind of push against the use of plastics in coatings, right? But then plastic-free material alternative coating would have to perform as a plastic-based coating. So that's a completely different discussion, right? But this is more for Xampla to demonstrate how good this is. For us, it's more about the showing that alternative proteins or alternative coatings like proteins or whatever they are, sugar, they are really plastic-free. Definitions,
very
right?
Specific,
very specific. But this can be as broad as possible, because you can claim that whatever I've done during the manufacturing process, I may introduce something plastic related, right? Completely different molecules. Then question from us would be, what is the quantity that qualifies your material to be plastic free, and who defines this quality in quantity? And that's what is missing at the moment. And that's what we need to get to regulations, and which will inform standards, and standards will inform regulations. It's just this vicious circle. Things.
What can listeners do to support the industry to adopt a plastic-free standard? Who wants to take that?
Well,
we get lots of questions in.
Well, I think this is the thing. There are different mechanisms to do that, but one of the mechanisms could be to develop, I don't know, a website, a web page, or a focal point for interested parties, especially interested to get into this consortium. And we often do that. We set up consortia to help us define a future standard. And of course, first we start with challenges, what the challenge is, technological challenge or regulatory challenge, and how we can convert it into measurement challenge. And then that will inform us what standards we can develop. So that's one way of doing this. The other way, of course, is to take initiative with 1 or 2, 3 companies and start talking to regulations and doing the process entirely with ISO and BSI as through normal routes. It may take longer, but I think it's a kind of a new territory for us for this particular area.
Okay, brilliant. Thank you. I've got so many questions coming in. I've got them on WhatsApp and on paper. Are applications for food packaging ensuring integrity of the packaging for several days rather than a few hours? For which products have they been tested? So has it been robustly tested over a range of different applications, I guess?
So what we have tested is actually a barrier coating made from our materials on paper. And traditionally, we've been, and the main focus of that product now is to be used in food service application. And again, but the scope of the test was actually to identify whether our materials were plastic free or not, regardless of what the end application is targeted for. But the majority of the products that are being used with our Moro coating at the minute are as a barrier coating for food service packaging.
Okay, brilliant. A natural unmodified polymer is not a plastic, in quotes. Okay, but if we produce a lot of it, then will it not just end up with the same sort of issues? I mean, it's sort of
Well, I guess one of the main differences, because obviously, I think we need to separate like 2 different things, like whether a material is considered a plastic or not, if it fits within some of the definition as defined by the Single-Use Plastic Directive, and then the completely different one is whether, even if it's not a plastic, what would be the end of life of that material?
Yes, of course.
And actually, it's an interesting. Sometimes I feel like it's more of a philosophical question, because I think there's great examples of completely natural polymers which are not very biodegradable. I think lignin, which is actually one of the most abundant natural polymers on the planet, it's not very biodegradable. And obviously, will it have the same problems compared to plastic? I guess hopefully the answer is no, because lignin already exists in like billions of tons in this planet, and it's part of our ecosystem. So from that point of view, we're not introducing completely new chemical back into nature. And I think that's why natural polymers are actually exempt from the definition of a plastic, because even if they end up sort of leaking into the natural environment, I don't feel that's going to be. Obviously, everything needs to be controlled and everything needs to look at in detail. Obviously, we should not be littering stuff. I think we want to make materials as circular as possible, and we want to make sure that materials can be recycled as much as possible. Or if they are composted or biodegraded, we certainly can ensure that those materials go back into the loop. And that's why we're kind of designing our materials to be applied at the right coat weights, and they're compatible with recycling infrastructure. They'll be biodegradable when they go into wastewater treatment plant. So I don't think that they will provide the same problems that plastic provides, which is a material that, especially in single-use packaging applications, we're using those materials for a relatively short time frame. And if we use plastic and it's not properly captured because we don't have the right infrastructure to capture that material, which is only used for a very, like I would say, hours, can potentially last for centuries in the natural environment. And I think that's why for certain types of applications, it actually makes sense to use materials that are natural polymers, are renewable, and they do not essentially harm the environment in case they actually accidentally end up leaking into the natural environment.
Okay. I guess one of the immediate aims of the Moro coding in applications is the operator's requirement to communicate to end users about what to do with that packaging, because they've been told for many years that paper has always had a positive story, and people have wrongly thought it could be recycled, and then they're told it can't be recycled, and now they're being told that it can be recycled. So there is a real job to be done to communicate, and you don't want people hearing about biodegradability and thinking they can throw their fast food and their packaging into a hedge.
Absolutely.
I mean, that's always been a challenge around the biodegradable story.
No, and I think, to be honest, paper is a great example of that. Paper is the biggest natural polymer,
of course,
on the planet.
Yeah.
Cellulose is the most abundant natural polymer.
Yeah.
So we keep talking about natural polymers, when in reality, paper is the greatest example of that, and it's very well established in this industry. So yes, everything we talk about here should be, talking like paper is the greatest example of that.
Yeah. Question around the Moro coding again. I know, sorry, I'm switching between plastic-free debates and the Moro. As the questions come in, I'm just doing them in sequential order, really. How would the coating be graded on the RAM in the UK? Because that's a big thing that we're dealing with in the UK. Is this assessed as paper and board or fibre-based composites, or does it depend on the percentage of the weighting of the coating?
I think I should know the answer. Actually, our business development, our head of business development, has been actively.
It's a big issue, big thing, isn't it?
Yes, and we do have the answer, but I cannot exactly remember what category it was considered. But we're certainly actively trying to work on that area to make sure it is in the right place, and that we are not affected by that.
Okay, I mean, one of the outputs of the webinar tomorrow when we do the email is
yes,
words around that, if you like. Any unique challenges and applications of these solutions in food applications against local food safety requirements? So are current safety standards achievable with these alternatives, or do the current safety standards need to be rethought?
No, so we are already compliant with food safety standards. I mean, fundamentally, we've been working with big packaging companies, and obviously they're experts in making sure that their products, including some of our barrier coatings, are compliant completely with the food contact regulations. So they've done all the testing and they've checked that, from a compliance point of view, everything. And that actually includes looking at raw materials, because obviously, so for example, there's guidelines, there's BFR guidelines in terms of what materials and chemicals can be used for food contact applications for paper and board. So we needed to make sure that all the raw materials we use in our formulations are part of the positive list, that there are no not intentionally added substances that are above the migration limit. So all of that work has actually been done to validate and demonstrate that our materials, when used in combination with standard packaging products, are compliant with the regulations.
Okay. I was lucky enough to have a demo about 90 minutes ago about how the coatings are applied to paper. But can you tell the audience how that's done?
Yes, and actually, very interesting question, because I guess that's one of the main challenges as a company. We want to develop solutions that are already compatible with the existing infrastructure. We do not want to develop new technologies that require a lot of capital investment or new machines, and that's part of our job as a material innovations company. It's not just creating new materials that can be essentially more biodegradable or can be considered plastic free. It's making sure that our customers, when they receive one of our materials, they can easily integrate it within their manufacturing process, their machines. And fundamentally, that's what we do. So we've developed and formulated our materials so that they look exactly the same as the type of materials that the industry has been using until now. So they don't have to change any of the processing conditions. So we just try to make that transition as easy as possible.
You're doing a fantastic job fielding so many. I don't think we've ever had as many questions as this for a webinar, which I think is fantastic. The old chestnut around percentage of plastic content has come up, because that's regularly debated on LinkedIn and various other places. So some countries recognise the plastic-free declaration using the 5% plastic content rule as compliant. This creates differences between EU countries, e.g. Poland does not recognise this 5% threshold, and a lack of trust, and that subsequently leads to a lack of trust among consumers and companies. That's more of a statement than a question, but are you able to sort of build on that challenge, that disparity?
I mean, yeah, certainly it is a disparity, because actually, I mean, what I find very interesting is that 5%, obviously, it's relative to the final weight of that product. So I guess if you have like a very thick cardboard, even 5% relative to that very thick cardboard, it's quite a substantial amount of material.
Yes.
That essentially will contribute to all the problems we've discussed before in terms of challenges with recyclability of paper. Obviously, that material not being able to biodegrade in a wastewater treatment plant, potentially contributing to microplastic pollution. So I guess from that point of view, I don't think people should be using the term plastic free in the context of having less than 5%, because certainly plastic will be part of that product. And I think it's misleading, and it sends a confusing message in the context of everything we've been discussing today about essentially being able to substantiate those claims. And so yes, I think it's the wrong terminology for that type of product.
Whenever I see a new product and it's described as paper-based, then that is a clue that there's an element of plastic within that product. Go back to Morrow. Can the Morrow coating provide a heat sealable layer on paper?
Yes, the answer is yes. So we have we have two main sort of formulations. One of them provides some greater water barrier properties, as well as heat sealing properties. And actually, we've been able to make to demonstrate actually in standard converting lines. So we've been able to make sachets. So like running like literally rolls of coated paper to make like individual paper sachets, and actually validating that essentially we can form a very strong seal, and the material can run on those converting lines at normal speeds. Also, some of the focus on our sort of R&D at the minute and next product development is on cups. So being able to form cups that have seal at the base and a seal on the side, and again, a lot of the development we're doing is making sure we actually can get the right seal, so the food's not leaking through. But that's part of our development, and we've made quite a lot of progress. So I would say for some products specifically, I think might be able to provide already the right performance.
Yeah.
For much more challenging ones, hot coffee obviously is the holy grail. That's challenging because
I feel like there's something coming down the line, and
it is maybe part of our of our challenges, and certainly that's what we're working to.
So the second part of this question from Andrew is his application is sachets, which you mentioned, which is a product category facing a potential ban under PPWR in just 5 years. So that sounds like a fantastic opportunity there.
Yes, and something to add is obviously us as a company, I would love to solve all the problems that people have in terms of being able to provide the right performance for lots of different applications. We can provide the right performance for lots of applications, but maybe not all of them, because some of them are extremely challenging, especially when we talk about long shelf life products that require extremely high oxygen, moisture barrier properties. And our approach there is that we can provide some performance in terms of heat sealing, some grease barrier, but we're open as well to work with other technologies to be able to find the right combination of materials and approaches that can actually deliver the performance required, as well as not compromising on the presence of plastic in this type of product. So certainly we're open to collaborate and to partner with companies that essentially might have synergistic technologies to solve those problems jointly.
Okay, we've got a marketing campaign suggestion here, which I don't think they're going to take a fee for. I can't believe it's not plastic. It's the suggestion.
It's a double negative.
Well, that's right. Yeah, that is a double negative. But then so is the butter brand, the non-butter brand.
Yes, that's right.
Do your coatings have heat sealing properties so as to seal the coated paper into objects? If yes, at what sort of temperatures range do they seal?
That's a very specific question. I'll probably like to essentially go and ask my colleagues in the lab next door. But fundamentally, I would probably say that maybe they would not require such high temperatures compared to standard materials like polyolefins and polyethylene. So some of these materials might be able to seal at slightly lower temperatures, and something that we would always test essentially, because depending on the thickness of the material and depending of the equipment and type of heat sealing units they might have, we might be able to adjust.
Okay.
But I have to say, we have been able, for example, to form cups on a standard cup forming machine.
Okay, brilliant. So what I'm hearing is there is a huge amount of work going on. There's a lot of development, a lot of opportunity to create bespoke, specific solutions for operators.
Well, we want to make sure we create the least disruption. So we will make sure our materials are as compatible as they can be with the existing machines, existing infrastructure. So we will not ask people to dramatically change the way they operate their machines, or build sort of new equipment within their existing lines. So that's our job. We want to make things a lot easier for the existing infrastructure, and not slow things down, because otherwise, we're going to make things less cost effective as well. So, and I think we're kind of already demonstrating this with some of our applications already in the market. We've been able to get the right code weights, to provide the right performance, and to essentially run our materials on standard machines, and that's what it's making essentially a success in certain applications. And that's part of our sort of journey as a material innovations company. We want to continue to develop the right solutions for all these different products. It takes a little bit of effort and time, but I think one of our main learnings is that through partnership with companies that have the knowledge, infrastructure, and the expertise, we are able to probably do that a lot more efficiently and a lot faster as well. And I think that's our model. We really want to partner with companies because we think that's the way to accelerate development and to get products into the market and to essentially develop products that have an environmental benefit a lot quicker.
Okay. So what's the best way for a company to start that partnership journey? What should they do?
I think they should just try to contact any of our team members. I think they can try to contact myself directly or any of our team members, like our head of business development or business development managers, our CEO. We're always open to talk to everyone and to really find those exciting new opportunities and partnerships.
Okay, brilliant. So we'll share email details and website and all that later. So Max, is there an open pathway for people to contact you with any sort of plastic-free technical and scientific questions and challenges?
Yeah, we do have on our website at NPL any questions or comments on, especially when people require some expert advice, they can contact NPL directly, and then it will be distributed across different areas. And finding the right one, use emails as well, so they're all free in the website. NPL is a big organization. We have plenty of methods and a lot of interest in the different areas. So I think there will be, even if we can't answer certain questions, others will definitely be able to help. And again, this is the important thing here, Mark already alluded to it, so that whenever we develop the standards for a material, it's one standard, of course, ideally, but even for the same material, when it goes to scale up and manufacturing and the big amounts of the standard can be modified to an extent because it will be a different challenge. So, or it will be the next standard. But anything new, especially in plastic-free area, very interesting to hear from people. So what challenges they have, they can be different.
Brilliant. So we'll share your contact details as well, Max. So Mark and Max, thank you very much for your time. Record amount of questions. I think you've broken your own record when we did a webinar with your good selves about 18 months ago. So thank you very much, both of you. This recording will be made available on our website, and every registrant will receive a link. We had one outstanding question which we'll clarify in that email tomorrow. So I'd like to thank you all for your attention and your attendance, and I look forward to welcoming you to our next PackUp webinar in due course. So thank you very much for your time.
Thank you.
Thank you.